Hello and welcome to my fourth lesson on statistics 2. And in this particular lesson I'm going to take you through ungrouped data, and as we look at that I want us to feature the following aspects. I want us to look at mean for ungrouped data, mode for ungrouped data, standard deviation, median, and the quartiles. So it will be pretty a short session. Now I need to mention this as we begin, that mean, the formula we use for mean is sum of x divided by n, where x are the values, actual values that you've been given for the ungrouped data. N is the total number of observations. Again, when you talk about mode is the most frequent value. Say if the performers in a cut had a case where many students had a particular value, that value will be the most frequent, so it will be the mode. When we talk about standard deviation, the formula is sum of d squared divided by n, and d is the x minus x bar. That means the values that have been given minus the arithmetic mean that you just got. The median, we just look for the middle value. I think I should mention that we don't use the median formula that we usually use for group data, because it's just a few observations. You can just arrange them and you get the middle value. The last thing that we look at is quartiles. In this case, the Q1 and Q3, which is a lower and upper quartile. And that means we're going to use this particular operation here to give us the lower quartile value and also the upper quartile value. And so I'll explain these concepts a lot more as we do the particular examples. And so maybe we begin with the mean. Now the example we're given is this kind of data here. We are given some number of values. They could be representing, say, populations of several towns in a certain country. Say there's one town that has 1143 people, another one has 1293, and on and on. So the question is develop or look for the mean for this. I find it a very simple concept, so I'm just going to pass over it really. Mean, I just mentioned that is sum of x divided by n, and the x are the values. This 1143, the 1293, the 989, and 1007, 1261, all of these ones represent particular x values. And so if you just add all of them and divide by the total number of them, then you're going to get your mean. In this case, n is 16 because the total number of observations are 16. That is 1, 2, 3, 4. If you count that way, the 1417 will be the 16th value. So mean is just that way. Adding these figures together gives us 18,577 divided by 16, and we get the mean simply. It is 1,161.06. And there's not much more I can say about that. So we go to the next concept, mode. Now when you're looking for mode, I think I just need to mention that mode is the most frequent value. So if in this data they're given here, if there's one value that exists a lot more times, then that qualifies to be the mode. And as we're given there's one town which has, there are two towns which has 1,357 people. If this data represents population of towns in a certain country, there are two times that 1357 appears. It is over here, and again it's over here. And so that qualifies to be our mode because all of the other values appear once. If there's one of the values that was existing or appearing, say 4 times or 5 times, that would be the mode. And so having mentioned that, that's basically what we do. Mode is the most frequent. In our case, it's 1,357. Now we move on to standard deviation. We look for standard deviation, and I mentioned earlier that the formula is a sum of d squared divided by n. We look for the square root of that. Remember, if we don't have the square root, then it is variance, but we are looking for standard deviation, which is normally a popular question that is tested. I also mentioned earlier that d is x minus x bar. In other words, the particular x values divided by minus the mean, arithmetic mean. In our case, it's 1,161.06. So we proceed, and as we proceed, I need to mention that because of the formula, the values that are given in the formula, that kind of points us to columns we need to have or to include in our table. This 892, 950, 989, 1000, 1007, 1073, and on up to 1417, all of those values there are our excess. All right, so they're just these values here. I've just put them in ascending order. You don't need to have them in that particular order, at least at this level. The next thing is I have looked for the value of D, this D here, which is the deviation from arithmetic mean. In our case, it's 892 minus the mean, that is 1161.06. So if you subtract, you get minus 269.06. Again, you have 950 minus the same answer, the same figure there, you get 211.6, and it's negative. The next figure, 989 minus 1161.06 gives us negative 172.06, all the way up to this figure here, which is 1417 minus 1161.06, and so the answer is 255.94. So that gives us the D value, which is the deviations from the arithmetic mean. Again, we go ahead to look for the D squared, which is just these figures here squared. Like negative 269.06 square, you get 72,393. The next figure, negative 211.06, you square, you get 44,546.32. We just go all the way up to 255.94 squared is 65,505.28, and so that's it there. That's how we develop the D squared. Remember, in a previous tutorial, I showed you how to operate standard deviation using assumed mean. So if you don't want to get big figures like this, you could have picked one of the values here to be our assumed mean, say 1000, and it'll be a lot more easier. You'll avoid getting big values for D's. You also avoid getting big values for this. I just hope it works, but basically that's how we look for the values, the columns that we develop in the table. So having said that, therefore, our standard deviation will be, you just get the figure you get down here. Since you looked for D, then you added that, you got 409,940.94. You just put it there and divide by 16. You find the square root of that. The answer will be 165.31, and that becomes our standard deviation. It's a very big number. That means that the data we have varies a lot. You see, the smallest number is 892, and the biggest number we have is 1417, and there are only 16 values, so there is a big variation from the mean, which is 165.31. Now, having said that, we need to move to the next thing, and it's median. So in median, we need to arrange the data in ascending order. Now, I have done it for you here. I have arrange them in ascending order. We have the smallest number is 892, followed by 950, followed by 989, 1000, 1007, on and on in ascending order up to the 16th value is 1417. Now these ones written in red here, or typed in red there, they are just numbering of the values that we have. Remember, these 892, 950, 989, 1000, 1007, 1073, these are the observations. These are the populations of the 16 towns. The smallest population for those towns was the one that was having 802 people. That was followed by a town which had 950 people, and on and on. The town which had the highest population, probably the capital of that particular country, is 1417 people. So this is just an ascending order. Now, how do we identify the middle value? I have a suggestion. We need to do it this way, and let me pick the pen there. Yes, we normally strike out this way. We strike that way, and then you strike the other side that way. We strike again 950, and you strike again 1357 the other side. We strike that way. We move until we get to the middle value. We should have one value left at the center there. However, in our case, it doesn't happen to be that way, and here it is. Please ignore the red colors there, or let me rub them for you. Yes. Yes, now you can be having a look at how it looks there. Now, having struck, I used a blue pen there. So yes, instead of the red. So I have struck the first one, the second, and the last one, the second and the second last, on and on until there was no median. You notice that we go to the 8th value and again the 9th value, and that tells us that we don't have middle value, because the middle value should be somewhere between 8 and 9. How is this the case? Because we have 16 values, and if you just divided this number, if you arrange the values in ascending order, you get 16 towns, sorry, you get 8 towns below and 8 towns above. So we don't really have a middle town in terms of the town which has the middle population. But if we had 17 towns, the 9th town would be the median, because we'd have 1 up to 8, and then the 9th, which is the middle value, and then 9 and 10 up to 17, which is another 8. So we'd have 8 and the 8 this side and a middle value. But in our case, we don't have the middle value. So how do we progress? This is what we do. We strike until we are left with 2 middle values, and we just look for the average. In our case, we'll use the average of the 8th and the 9th value, because those are the 2 middle values. So we would say that the median of these is an average of the 8th and the 9th, and so we just progress looking for average as it's already known, a simple concept. Just get 1,143 plus 1,197, add, divide by 2, and the answer will be 1170. And that's that. One more thing I need to mention: we don't use the normal median formula in this case, because these are numbers which you can just add, we can just arrange in ascending order and get the middle value. So in that case, we don't need the median formula, because again, it's also not grouped. And that's that. Now we go to the last concept, and it's quartiles. Quartiles are very much related with median, and so we begin by saying this: the quartiles are boundaries dividing the data into 4 quarters. All right, and this array here brings that point, or clarifies that point. And these are the towns. You know, there was a town which had 802 people. There's another one which had 950 people. Another one, the 4th town, had 1,000 people only. The 8th town had 1,143. The 12th had 1,293. They are arranged in ascending order until the last town, which had a population of 1,417. So we have 4 boundaries which divide the data into 4 quarters. If we have a value here, we would have 4 values below it, and 4 values, then another value, then 4 values up there, then another value, and 4 values, such that that one there happens to be the first quarter, or the lower quarter. Okay, if we add a value here, it would be dividing the data into 1 quarter and 3 quarters. Again, the one at the middle here would be dividing it into 2 quarters below and 2 quarters above, and that means that's actually the median. Sorry. Again, we would have that value here, which would have 3 quarters and then a quarter. No wonder we normally have this value here is low quartile, and this is the second quartile, let me call it that way, but it's a median, and this one is the upper quartile. So maybe I should mention that the median, which is the second quarter, has been done by just averaging, or looking for the average of the 8th and the 9th, the population of the 8th and the 9th cities or towns. So how do we do Q1? The lower quartile will be the average of the 4th and 5th, because we don't have the lower quartile boundary. We don't have a boundary. We don't have a figure here. Since we don't have it, we just average the 4th and the 5th. I should say something. If these figures were 17, if the total number of cities was 17, we would have, I think 5 would be the lower quartile, because we would have 5. We would have a value at the center there, but this one doesn't have. Remember the case I said about the median. If we had 17 towns, we would have a value which would have been the 9th, and so if this would be the center value, we would have other 2 values here. Sorry, I think actually if we had 17 values, even then we would not have the lower quartile. So even in that case, we would average the 5th and the 6th. So please get the concept. When we don't have the lower quartile or upper quartile or median, we normally average the 2 that represent that particular value that's being looked for. In our case, the lower quartile will be the 4th and the 5th. You average those 2. So it will be 1,000 plus 1,007 divided by 2, and the answer will be 1,003.35. I think that's simple. We go to the upper quartile, which is Q3. It will be the 12th and 13th. The average the 2, and that's clearly indicated here. It's 1,293 plus 1,333 divided by 2. You add and you divide by 2, you get 1,313, and so that's our mean. That's the upper quartile. Now, to wind up the lesson, I'm going to mention something about the interquartile range. In a previous tutorial, I told you it is the upper quartile minus the third quartile. So in our case, it will be 13 minus 1,003.5, and so the interquartile range is 309.5. Again, you see, the same data was used to develop the standard deviation. Standard deviation was a big number, 165 point something. Look, the quartile range is also a very big number. So that tells you the numbers are so much varied. Again, we have the quartile deviation, which is a half of that. It's interquartile range divided by 2, so it will be 309.5 divided by 2. And so the answer will be 154.75. And so that marks the end of all the concepts that I wanted to show you in statistics 2. But shortly, or the same time with the time I'll be posting this, I'll also post a video on statistics 1. Just some 2 concepts that I found important, and you'll be done with all statistics. Thank you. I hope you appreciate it.